Good afternoon, students. So we are on the passage of seeing about medical electronics. So I think this is the third session. So far whatever we have seen. So previously, in the first class we saw about why medical electronics, what medical electronics plays role in the society, what is the importance, what are the responsibilities for medical electronics engineers, and so on. And also we saw about what are the activities totally we are going to see, industrial visits, and so on. Then we saw about the first title was infrared thermometer. So we saw how it works, what is the principle of operation, and what is the difference between IR thermometer and infrared cameras, surveillance cameras, and so on. In yesterday's class, we saw about biopotentials. So we saw about how the voltage gets generated inside the human body. We compared the human body with the robot, with the systems that are interrelated with them. And we saw how the current flows through the body. So in electronic circuits, it is electron current. Inside the body, it is ionic current. So we are going to deal with ionic current and finally lead out with electronic current, right? So today we will see the first title as electrodes. So before going to electrodes, instead of having the activity at the last, we'll start with an activity. So you see, listen here. So I have an equipment which is called as oscilloscope. This would have seen it in the lab, right? So now what I'm trying to do is I'm going to do a simple measurement. If there are many students that are called one. So here you can see that there is no signal, right? So I'm going to perform a basic measurement operation. So there are two lines here. So this wire is called as a probe, right? So probe is the wire which is used to carry the signals. So it's a medical term. So now you can see when I try to see there is no signal. When I try to touch this signal, this metal tries to pick up some signals from my body. If I try, this is one of the terminals. When I try to touch both the terminals from the same place, you can see the amplitude is somewhat reducing. So no signal. Now we are trying to get a signal. Now if I post a question about from where this signal came from. So previously you would have thought that it is from the surroundings or a noise. If so, then wire is an antenna, right? For example, in FM radios, wire is considered as an antenna. It's an antenna too. So it should have picked up. Now it is not picking, whereas now it tries to pick up the signal. So this makes the difference. So the signal has come from our own body, or it has picked up from my body. So that is the basic measurement, right? So now the question is, if I ask you from where the signal exactly came from, nobody has an answer. It could be from my hand or from anywhere in the body. So that makes the need for electrodes. And also if you see, the signal was almost like a noise signal. We were not sure about the pattern of the signal, the wave shape of the signal. So these are all the troubles that we have when we roughly go for a measurement. So that is why we need electrodes here. So electrodes is also a metal like this cable wire. This is like metal, right? So electrodes are also a metals, but they are designed precisely for the picking up the signals. So that's what we are going to deal with. So let's go again. So the need for electrode is to pick up correct signal from the correct part of the body. So that's the need. Else we will get a signal, but we cannot identify what kind of signal, where it originates from. So now this is about the types of electrode. So electrode is needed to pick a signal. So electrode from school you would have understood that it is simply a metal or something like that, right? In a beaker they will try to keep two electrodes and a solution, electrode is solution, current flows and so on. So basically it's the same definition. Electrode is a metal kind of thing which we are going to use. The type of metal will differ from different types of electrodes. So now these electrodes, there are many types. Basically they are classified into three types. So one is microelectrode, then comes needle electrode, then there is another type which is called as heat surface electrodes. We will see one by one. So microelectrodes, again it is further subdivided into metallic microelectrodes and non-metallic. So from the name, metal is used means metallic microelectrodes, non-metallic. Then comes needle. There is no subdivision. There is only one type of needle electrodes. skin surface electrodes or surface electrodes we call. So that has around 5 types. So it is metal plate, suction cup, floating electrode, disposable, scalp surface electrodes. We'll see one by one. So first going to, so the first type was micro electrodes, under that metallic micro electrodes. So micro electrodes, from the name micro, what is understood? Micro means small. So the actually here the electrode is here in the tip. So these are all the holding arrangements. So it will almost look like, this is how it looks like. It looks like a pencil where the tip has the graphite which is used to write. So this is all for holding and all these things. So micro electrodes has a minute, for example, it has its tip under 1 or 0.2 millimeter kind of diameter. It's very small that you cannot see. It just penetrates the skin. It is like an injection tip. That's how it looks like. So there is a metal, a small micro metal, so which actually goes into the surface of the body, from where the signal picks up. Then there are 2 wires from where the signal is picked up. So you can see that there is a gold plated pin connector from where the probe is taken and is given to an instrumentational amplifier to amplify. So this is how it looks like. So metal micro electrodes. Micro is a small one. Metal is used here. For example, the next one you will see that it is a plastic one. So here metal is got used. So that is why we call it as metal micro electrodes. The next one is non-metallic or micro pipette electrodes. So pipette you would have seen in schools, right? To pick up some liquid, we use pipette and we'll try to take it. So similarly, this is also something similar to a pipette kind of arrangement. You can see that it roughly looks like a pipette and is made with plastic kind of glass materials. So that is why it is non-metallic. And also even the tip, there is no metals involved, it is only plastic. But you see why it is called as micro pipette. The diameter of the tip is only 10 micrometer. 10 micrometer is very, very small, it is a small thing. And here the contact between the body and the signal electrodes there is no metal involved, there is only an electrolyte solution which is involved. So when we try to put this electrode somewhere in a part of the body, actually the plastic tip which is 10 micrometers gets in touch or penetrates the skin or goes to whatever place it needs, like muscle or whatever. So from there the body has muscle fluids, that fluid and this electrolyte solution get into contact. From there the ionic signal goes to the wires. So here we have electrodes to take out the signal. So it is Ag silver chloride electrode is there. So the silver chloride electrodes will pick up the signal and from there it is carried out, it is given to instrumentation amplifier, right? So this is the second type. So in reality it looks like this. See, if my hand is this much, so it is very small, very tiny, right? So that's how it actually looks. Then going to the next one, as the name indicates, needle means where do we use? To stitch cloths or an injection, we tend to use a needle. So as there is a needle or the electrodes is in the form of the needle, we have named it as needle electrodes. So this is used in places where the interference should be minimum. So what does interference means? The disturbance from the neighboring or surrounding place. So that is called as interference. Interference means interfere. Interfere means involving. So interference wherever it needs to be low, we'll go with needle electrodes. Needle is it's like a small injection. So it goes exactly to that specific part where it needs to pick up. So mostly we will try to use this needle electrodes in EEG measurements, electroencephalogram. So in further classes, we'll try to see what is electroencephalogram. Basically, it's a study about the electrical potential inside the brain. So according to the brain activity, the EEG signals will vary. So to measure that, we try to use this kind of needle electrodes. So by that you don't need to go to a confusion of whether this needle will go inside the scalp and then inside the brain. It's not like that. So this will simply touch the scalp. it will not penetrate the cell, it will touch the skin. So this skin alone it will try to touch, it cannot penetrate inside the scalp and go inside the brain or do something like that. For more precise picking up the signal, you use this needle where it exactly takes from that place. So this needle is of metal type and it is connected to a wire or a probe. So we cannot call it like a wire in medical electronics, we will call it like a probe. So it is connected to the probe. From there you can see that there is a probe available. So this probe you take it to the instruments and for the measure. So that is how it is. Next one, surface electrodes. So there are basically three types. So one is micro electrodes, then comes needle electrodes. So needle electrodes specifically for EEG at a particular portion of the brain if you want to measure it. Then comes surface electrodes. So surface means what? Surface means outer portion. So surface electrodes means these electrodes will be placed on any surface of the body and it is not going to penetrate in like micro electrodes or needle electrodes. The first type, so these are 5 types, so today we will try to see few according to the time limitation. The first one is metal plates electrode. So this is the real pic, right? So this is how it looks like. So the metal means the electrode is here, so this is made up of a metal. So then for example, if I am going to put it in my arms, so I try to place this to have a grip. So we have a holder or a belt kind of arrangement. So the belt according to, we have holes here, so they try to tight it. So this is the actual electrode. So the signal gets picked up from this point. So any metal picks up the signal. So here we will try to put it. So most probably it is used in places where it is used in arms or thighs. So that's the place we need to use it. There is only one limitation. You can see that the limitation is slippage. Means if the person is trying to move, then the electrode also moves. Then there is a slippage, so we will not be sure whether it is picking up the exact signal. It can pick up the other signals too. That's the only thing. So we have to have a grip, so we have a rubber support and all those things too. So from here, the signal is being taken through a probe. So that's called as a lead wire. So from where it is taken. So it's a simple arrangement, right? So then next comes which is called as suction cup. So suction means what? Suck the air which is inside. So the kids would have played the arrows, or even in our car, the cell phone holders, we will try to use this suction cup, right? So we'll try to place this, and then when we do it, it sucks the air, and then that's how it is attached with the grip. So that principle is what. So wherever you need more grip and there is no other movement, will always go for suction cup electrodes. But you need to remember one thing, it is not that one electrode has so many advantages, other electrodes has disadvantages. Every electrode has its own application and own place of application. For example, this suction electrodes cannot be used in arms nor in any other places. But in chest, it is well suited. Wherever the surface area is more, you can use the suction electrodes. For example, in real time, so in the chest regions, this is well and good, but this is not good for arms or not even in head regions you cannot keep. Wherever the surface is not flat, you cannot go for suction because only when there is a flat and polished surface it can suck. If there is a small hole, the suction doesn't work. So every electrode has its own advantages, disadvantages. Accordingly, it is being applied. So this is used in such places like for ECG measurements, electrocardiogram. We take to study the activity of the heart, or breathing, means lung breathing capacity, and all those studies will try to use it. So this is how the patient taking to measure. So we have a knob, so through which when we tight, so the suction becomes too heavy and the signal which is read will be proper. With more accuracy depends upon more kind of sucking up or more kind of attachment. So that's the thing. So there is a thing. And other than that, as like normal electrodes, you have a metallic tip, so that will be attached. So from there, the signal is being taken. It's very clear from here. So you tend to take the signal from these electrodes given to equipment, right? So this is suction cup electrodes. So this is also kept in the surface of the body, right? That is why it comes into surface electrode. Another one is you can see the disposable electrodes. So disposable electrodes, if you see, the word disposable means what? Once you use, and it can be used to recycle and it can be thrown away. Disposable syringe. So that we are very used. So one time use, right? So that's what this is all about. So this is also a surface electrode. Most probably you have seen this in all hospitals, right? So there will be a white color patch from which inside there will be a metal surface. So this is also kept on the surface. So that is why it comes as a surface electrode. But it is one time use. You take to have a glue material. So you tend to take the outer cover. There will be a ready-made glue. Wherever you want to keep it, you try to keep it, and from there the signal picks up. So that is how disposable electrodes works, and this is also used for ECG measurements or EMG. In any parts of the body you can stick it. The glue is very adhesive, is very good. So, but it's not good always. Only once used we can tend to use. Then the next one is called as floating electrodes. See, the floating electrodes and disposable electrodes are almost 95% same. There is only one thing that differs. This construction and the previous construction is also the same. Only difference is the previous one is one time use, and if it is multi-time use, it is called as a floating electrode. You can see the floating electrode also looks same as disposable electrodes. Only thing is that you have both the electrodes look similar. Only thing is that there you have a ready-made glue, and you remove the external plastic coat, you remove it and you stick it, you use it, throw it. Whereas this one is reusable. So what we'll tend to use here, we'll tend to use an electrolyte solution, like a jelly solution. So first of all, they'll try to clean the surface, because any dirt on the skin surface will block the signal. So dirts are all inert. It means dirts are all they are insulators kind of thing. So they'll try to remove, then clean, and then apply jelly. Then they will try to place it from where the signal picks. So floating electrodes and disposable electrodes both are surface electrodes, both are similar. Only it depends upon a ready-made glue or what we tend to use it on the hospitals, reuse again and again. But the only thing is disadvantage here is we need to have a skilled labor, a person who knows it, properly cleans it and tend to fix it. Because on multiple usage, for example in contagious places, we cannot go for this, whereas we can go for the previous one, like use and throw, right? But on repeated usage, if you want to be cost effective, then you need to go for this kind. But both operations are similar. So there is a metal, and from there the signal picks up. You can see that it is the same metal, silver chloride. So we saw in micro electrodes like AgCl. So it is silver chloride is only present. So from there the leads, I think it's not properly visible. Leads is there, so it is taken. So we have a plastic rubber support. All these are to keep it. So that is a brief about electrodes. And the last one is called as ear clip electrodes. So as the name indicates, ear means our own ear. Clip, you know, from the cloth clip. So it is something with an elastic arrangement. So this rubber clip electrode for ear clip electrodes, this is how it looks in the rear. So ear clip electrodes is used to keep the electrodes on the ear. So because it should not move. So there is sometimes if needed, they will even keep it in your fingers whenever it is needed. Mostly this ear clip electrodes is used as reference electrode. So there are two electrodes or two lines. So one is signal line and the other one is reference line. So for example, in ECG, if we are trying to take 5 signal lines and in posterior regions, so it's mostly used only in EEG, electroencephalogram, when they tend to pick up a signal with reference to what they are trying to see. So with reference to always they will go for an ear. So here you need a clip, but the electrode is actually here, from where the signal takes. So it is like an earphone, you have a clip and that's how it goes. So you press this gets open, these two things gets open and you can keep it so from wherever it keeps. So this will not pick up the signal, it is used for a reference, with the reference to what? So that's how I mentioned. So it is used as a reference electrode. So this is the role of electrodes. The simple thing is to pick up the signal, as how we have seen. And depending upon the usage, we have different types: metallic electrodes, non-metallic electrodes, needle electrodes, and then comes surface electrodes. So you cannot use surface electrodes in where needle electrodes need to be used in EEG measurement. In needle electrodes, you cannot use for ECG where surface the signal has to be present. So every electrode has its own positive or merits and demerits too, and that's how it finds its application. So that is all about electrodes.
So your presentation is really good. So in my suggestion, so better you show some body of human body. So based on that, you can place some components in. For example, you shown some ear electrodes means. So you place some components in an ear. Then after that, you can show some GIF images. So once we are inserted some that is electrode means. So what will happen? Suppose it gets a signal. Then what type of signal it is? Then how we are measuring? Just 1 or 2 second clips. So that is easy to understand.
Maybe like this. It will
So,
give it real time.
yeah.
Okay.
So we can show some zip. For example, we are placing some electrodes in our body. So after we place that, so what type of signal we are measuring in the output side? Just for understanding.
Okay.
So then after that, so you showed some real pictures for some electrode, only few electrodes. So better we can give some real-time examples for all type of electrodes.
I thought of it, I was running out of time. Possibly I will include real-time and also like this kind of pictures where they know where it is actually used. I got only for one electrode. Even for these electrodes, if it is, it will be useful. Sure.
Then for a simple understanding, once you complete this particular topic means, finally you can put some tabular column. So once we are using floating electrode means, then where we are placing. So in our body, so ear electrode means, so in ear. Okay, so then after that, so what type of signals we are getting? So in terms of waveform format or in terms of the picture format, like that. So we can easily understand the concept.
Yes. Okay, sir. Try to go with it. Thank you.